Hey everybody, welcome back to your last packet before spring break. Woo! This is your video lesson for 6.1, section 6.1, day 2. So we're learning 3 new properties of exponents. We learned 2 last class. Those were how to work with zero exponents, which are really super easy, and how to work with negative exponents. And we're going to need those, as you know, math always builds on itself. So we're going to use those today as well. So hopefully you feel pretty confident with those. Okay, so I'm going to do my best to make it take a little less time than last time. My last video was a half-hour long and not too many people watched it. So hopefully this will be quick. I'll go through them. We'll do some examples and that'll be it. All right, so the first property that we have to talk about is the product of powers, so also called the product rule. All right, so first of all, if we're multiplying, product means multiplication, all right? That's one thing, you got to know these words, you got to know what they mean. Product means multiplication, so when we multiply powers together, in words here, you can see what it's saying there. To multiply powers with the same base, add their exponents. Okay, now, that's important. They have to be the same base. You can't simplify powers that have different bases. So, for example, x squared times y squared, we can't combine them. We just kind of throw them next to each other. We say it's x squared, y squared. Okay, there's nothing we can do to simplify them. So it sounds simple enough, right? To multiply powers with the same base, you just add the exponents. All right, now, first off, I think it's important that I'm going to zoom in a little bit over here. All right, I think it's important that we talk about why it works. All right, so real quick, if I could just show you here. If you look at this sentence, this is the rule that we just talked about. If you have 2 to the 3rd power and 2 to the 5th power, you get 2 to the 8th power because we add that 3 and that 5 and we get 8. All right, so here's why it works. If we expand these powers, then you'll see why it works, because 2 to the 3rd is 2 times 2 times 2. When you multiply that by 2 to the 5th, or 2 times 2 times 2 times 2 times 2, okay, that's what they are when we write them in expanded form. And then we take 2 to the 8th and we write that out in expanded form. We get 8 2's multiplied together like that. So if you really look at the two sides, they're the same. We're multiplying 3 2's and 5 2's that are all being multiplied together. So we have 8 2's being multiplied together on the left side, and we have 8 2's being multiplied together on the right side. Both sides are the same. So if the two sides are the same, then you know it's got to work out. All right, so let's look at some examples here. All right. Okay, trying to get the zoom right. All right, that's going to bother me. All right, so let's look at some examples. All right, first off, we're going to do 3. I'm going to do 3 with you, and then I want you to pause the video, and I want you to do 4 and 5 on your own, and then you can push play again and see if you got them right. All right, so honor system, do it along with me. All right, so a to the 4th times a to the negative 3rd. All right, the first thing we're going to want to do is we're going to follow the rule. So we're going to take those two exponents. We have the same base, a and a. So we're going to add those exponents. And even with negative exponents, it still works. So there's no sense in changing this a to the negative 3rd to 1 over a to the positive 3rd. We can just go ahead and use the rule here. I think that's the easiest way to do it. So you get 4 plus negative 3. 4 plus negative 3 is positive 1. So if you just have a to the 1st power, then our answer in perfectly simplified form would be a. Number 2, you can see we have different bases here. We have a and b times a and b. So all we have to do, one thing you can do is you can rearrange the terms to make it easier on yourself. So remember, everything here is being multiplied together. We can multiply things in any order we want. So this a, I'm going to put my a's together, a to the 1st power. If it doesn't have an exponent, remember, it has an exponent of 1. And then a to the 5th over here. So I put those together, and then I take my b's, I put those together, and then all we have to do is add like bases, add their exponents. So 1 plus 5 is 6. 2 plus 7 is 9, so we get a to the 6th, b to the 9th. It's that simple. We can't simplify a and b together, so that's as simple as it gets. All right, number 3, some weird things that can happen when you're using the product rule here. Okay, so we can see we have opposite exponents. And when we add opposites, we always get 0. So what is x to the 0? What is anything to the 0 power? It is 1. Remember, it's not x to the first. It's not 1x. The x is completely gone. It's just a 1. That's all we get. All right. Pause the video and try the other two on your own using those same rules. Okay. Did you do it? I hope you did it. All right. So the answer to number 4, let's take a look, is y to the 5th. All right, when you have 3 bases like that, you just add up all 3 exponents. You got a 7, a -3, and a +1. Number 5, your answer should have been k to the 3rd, n to the 3rd. Because if you check out the m's, I'm going to get my lightsaber out here just because it's so much fun. M to the 4th, m to the -4th, those are opposites. So you're going to get m to the 0, and that is equal to 1. We don't really have to put that 1 in there because multiplying by 1 doesn't do anything. So it kind of just drops out. You just have to know that that's equal to a 1. When you multiply by 1, it doesn't change anything. All right, so 1 property down, 2 to go. Quotient, the quotient rule, quotient of powers, okay, that means we're dividing 2 powers. So as you might imagine, dividing is the opposite of multiplying, which we just talked about. So instead of adding exponents, we're going to subtract the exponents. You can see our rules here in numbers. All you do is 4 to the 6th divided by 4 to the 3rd. You just subtract the exponents and you get 4 to the 3rd. And here for any algebraic, we're going to take a look at some examples of those. So let's get right into it. Why does it work? All right. Well, look at here. Okay, there's 2 ways to think about this. You have the rule, which is right here. So 4 to the 5th divided by 4 to the 3rd, you would subtract the exponents, you get 4 to the 2nd, and that's equal to 16. If you use the expanded form, okay, let's just reveal this here, then 4 to the 5th is 5 4s multiplied together, and 4 to the 3rd is 3 4s multiplied together on bottom. So if you have a 4 on top and a 4 on bottom of a fraction, those are common factors and they reduce to 1s. So every 4 that matches up on top and bottom, they kind of cancel each other out. They become 1s. And just like that problem before, when we multiply by 1, it doesn't change anything. So they really do just kind of drop out. And then you kind of look at what we're left with. Okay, so all we have on bottom is 1. What we have on top, we have 2 4s left over that didn't get canceled out, so to speak. So what we really have is 4 times 4 on top and 1 on bottom. And we all know that that's equal to 16. So by expanding these, you can prove that the rules make sense. And now at least you know where they're coming from. All right, so that's our rule. When we divide powers with the same base, we're going to subtract the exponents. Okay, so keep in mind when we're subtracting, that's when things get a little confusing. So I wanted to start off with an example here in example 6. I've got, like I said, we can go ahead and use the rule even if we have negative exponents. It still works. So you're more than welcome to flip this around and write it as a to the +2 over a to the +5. That's how we would use our negative exponent rule. But really, if you just take a look here, you can write it out just like you're supposed to, -5 minus -2. Now, keep in mind, there's a lot of negative signs there. You got to make sure you include them all. Okay, you can't just leave one out because you're going to get the wrong answer. All right, but anyway, if we plug that into the calculator, we get a to the -3rd. And then, of course, we never want to leave negative exponents in our answer. So we need to make that positive by flipping it to the other side of the fraction. If it's on top, we flip it down to the bottom. Okay, number 7. Okay, we got a couple different types of bases here. We got a B and a C, but again, we just simplify the B's, we simplify the C's separately, and then we just kind of throw them together at the end in one expression. So B, we're going to subtract 2 minus 3, so we are going to get a negative value there for B. C, we have more C's on top than we do on bottom, so that's going to give us a positive result, 2 minus 1. That gives me B to the -1 and C to the +1. So again, I don't want to leave a negative exponent, so I'm going to move that B to the bottom, but the C has a positive exponent, so it's going to stay on top. And those 1, they both have an exponent of 1. We don't need to show those. So you can write the 1s up there if you want. It's not wrong. I would never count it wrong, but you're not going to see them written that way, so it's a good habit to get into to simplify everything as much as you can. All right, number 8. I threw a couple numbers in here as factors as well because I want you to understand that numbers are still just regular numbers. They do regular number things, okay? These new rules are for exponents. They're for powers only. So when we're dividing 2 and 6, we don't subtract them because they're just regular numbers. So we just simplify that fraction. So let's take a look at how that's going to work. I think it's a good idea to separate them out. Create a fraction with just your numbers. Create a fraction with just your variables, your powers. All right, and then we simplify them both independently. So 2/6 it can be simplified to 1/3. And the x's, we're going to subtract those exponents. When they're the exact same, this is going to make a lot of sense. We're dividing one number by itself. Anytime you do that, you get an answer of 1. Well, look what we get here. 1/3 times x to the 0 power. When we subtract the exponents, we get x to the 0. And everybody knows that x to the 0 is 1. So we have 1/3 times 1, which is essentially just 1/3. So this whole thing here simplifies down to 1/3. All right, so make sure you go all the way down. Make sure you simplify the numbers as well. All right, pause the video. Try numbers 9 and 10 on your own, and then check out and see how you did. All right, go ahead and pause it now. All right, let's see if you got them right. Pat yourself on the back if you did. All right, number 9 is ab to the 3rd, or a to the 1st, b to the 3rd. Hopefully you got that one right. 10 was a doozy, but there's a lot going on right here, but just take it one pair of bases, like bases at a time, okay? The numbers, 9 divided by 3 is 3, so we're going to have a 3 on top. When we subtract the x's, we get x to the 5th, because 3 minus negative 2 is actually like the same as 3 plus 2. And then we have -1 minus 4, which gives me a y to the -5th. So we have to move that to the bottom, make it positive. And then the z was all by itself. It didn't have any buddies to hang out with. So he just stays right where he is. That z to the 6th doesn't move. It doesn't change. Okay, let's move on. Next, we got 2 down, 1 more to go. I think I'm already at 12 minutes. I don't even know how to do this, how to make it short. But this is probably not helping, right? All right, so our last rule is power of a power. And that means, okay, so you can see in the examples here, let me get out my little, hopefully you guys can see this little red dot that I keep putting everywhere. So we got 4 to the 6th to the 3rd power. So it's not 2 bases being multiplied together. It's 1 power being raised to a power. So in that case, when that happens, we multiply the exponents. All right, so here's how it works. 4 to the 6th power raised to the 3rd power is 4 to the 18th power, because you multiply the 6 and the 3. All right, here's why it works one more time. All right, we are going to go to the expansion. All right, so when you square something like 5 to the 3rd here on the left side, you are multiplying it by itself. So what this really means is it's 5 to the 3rd times 5 to the 3rd. And over on the other side, we have 5 to the 6th. Okay, well, now, if we expand all of these, 5 to the 3rd is 3 5s multiplied together. 5 to the 3rd is 3 5s multiplied together. So on this side, we have 6 5s being multiplied together. And on this side, 5 to the 6th, we have 6 5s being multiplied together. So when you break it down, you see the two sides are exactly the same. That's all good. So that's why it works. All you have to know is that it works and how to use it. All right, so just a few more problems here to talk about. We'll do some examples, and then I'll turn you loose. You're going to be good to go and finish the rest of this packet. And remember, on my notes, these are the notes that I'm showing you right now. These are on Schoology, and I do also give you some help with some of the practice problems on there. So I solved a couple of them for you just to get you moving in the right direction with some of those harder ones. All right, so number 11. We've got a to the 8th. Raised to the 3rd power. So we are going to, that is one base being raised to a power and then being raised to another power. So that is, we're going to multiply those exponents, not add them. And that gives me a to the 8 times 3, which is a to the 24th. And there's not much else we can do with that. Number 12, b to the -3rd to the 5th power. Okay, same thing. We could change this to 1 over b to the +3rd, but we really don't need to, because the rule still works. All we got to do is multiply, and we can do that. We can, if we have a negative exponent, we can change that at the end. It's a lot easier to do it that way. So b to the -3 times 5, that's going to give us a -15. You do have to watch your signs here when you're multiplying, just like always. And then, of course, we can't leave our answer as b to the -15. So we have to flip that down to the bottom of the fraction to make it positive. And there's our answer with no negative exponents. All right. Last one that I'm going to do with you, number 13. All right, so we've got two different situations here where C is being, this is a power to a power here, this is a power to a power here. So we're going to simplify both of those by multiplying first. All right, we use the power property, or the power rule as it's called, and we're going to multiply 2 times 2 and get C to the 4th, and we're going to multiply 3 times -4 and get C to the -12th. Now we use the product rule because we have two different bases, both with their own exponents, being multiplied together. So we add those exponents, and we get 4 plus -12 is going to give me a -8. So if my answer is C to the -8, just like this one, you know what I'm going to do. I'm going to flip that. I'm going to put my thing down, flip it, and reverse it to the other side of the fraction. So our answer here is 1 over C to the 8th power. All right. Now, you pause the video here and try and get 14 and 15 figured out on your own. I guess I'll sing you a little song while I wait for you to pause the video. What's in my head today? Why men great till they gotta be great? Don't text me, tell it straight to my face. Best friends. I don't even know how that song goes. It's in my head. It's been in my head all day. I'm glad I could share that with you. All right. Sorry about that. I've been going crazy in my house. I've been cooped up for too long. I know you all are too. All right, so I showed you some of the answer there before. This is your final answer for number 14, 1 over x to the 24th. And for 15, you see that 32 there, it's y to the 32nd power, because you're going to multiply these and get 20, multiply these and get 12, and then you're going to add the two powers, the exponents of the two powers being multiplied to get 20 plus 12 is y to the 32nd. All right. I just took a DNA test. Turns out I'm 100% Mr. Schaub. And that is my video lesson for section 6.1 day 2 in under 18 minutes. You're welcome. All right. Email me with any questions. I'm available till 3. Hit me up, and don't forget to get that stuff turned in by 8. Late.